We have another example. So we have to start solving this problem from finding the impedance of the capacitor. So I'm going to write the formula over here. Z of C is equal 1 over 2 pi f C. Okay, this is my C1. Let me call this ZC1. Okay, so this is equal 1 divided by open parenthesis, and I have 2 pi times the frequency is 400 Hertz, times 400 Hertz, times C, which is equal 100 nanofarads. Okay. So my ZC1 is equal, let me find this by the calculator, 1 divided by open parenthesis, we have 2 pi times 400 times 100 exponent 9 negative, close parenthesis, equals. Okay, this is equal 3.97 coulombs and angle of negative 90 degrees. Okay, so keep in mind that anytime we talk about the impedance of the capacitor, we're supposed to add angle negative 90 degrees. But in order to make this problem a little bit easier to calculate, I'm going to write that Z of C1 is equal approximately 4 coulombs, because 3.97 K is almost 4 K, and of course angle negative 90 degrees. Okay. So next I'm supposed to find the admittances. So I'm going to have admittance called YC. Okay, YC is equal 1 over Z of C, which is equal 1 divided by 4 coulombs and angle of negative 90 degrees. This is equal 250 microsiemens and angle of 90 degrees. Next, we're supposed to find Y1. Okay, Y1 is 1 over R1, which is equal 1 divided by 2 coulombs, and this is equal 500 microsiemens. Next, I'm supposed to find Y2. Y2 is equal 1 over R2, which is equal 1 divided by 1 coulomb, which is equal 1 millisiemens. Next, I'm supposed to find Y11. Y11 is equal the sum of the admittances going to the node 1. This is my V1, this is my V2, and this is my reference node. So I have V1 and V2. It means I need two nodal equations. So I have Y11 is equal to the sum of YC plus Y1. Okay, because these two are connected to the node 1. So I have YC is equal 250 microsiemens and angle of 90 degrees plus Y1, which is equal 500 microsiemens. This is equal, I have 250 exponent 6 negative angle 90 degrees plus 500 exponent 6 negative. This is equal 559 0.01 microsiemens and angle of 26.56 degrees. Okay, so this is my Y11. Next, I'm supposed to find y12. y12 is equal to y21, and this is equal, in our case, to y1, okay, because y1 is the admittance between node 1 and node 2. So this is y1, and this is equal 500 microsiemens. Next, I'm supposed to find y22. y22 is the sum of the admittances connected to node 2. Okay, so I have y1 plus y2. So I have y1 plus y2, where y1 is equal 500 microsiemens plus 1 millisiemens. This is equal 1.5 millisiemens. Next, I'm supposed to take a look at the currents. I have to find the sum of the currents at node 1. Okay, so what we have? The current I1 is leaving the node, that's why I'm going to write the negative. So this is negative I1, and current I is coming to the node. Okay, so that's why I'm going to write plus I. So I have negative I1 plus, and I is equal 4 times of the current which goes through the capacitor. So let me copy this down. This is 4 times IC. But we do not have IC. But we can find the formula for it. So this is equal, let me copy down, negative I1 plus 4 times, and IC is nothing else, just voltage V1 divided by impedance of the capacitor. Okay, because V1 is the voltage across the capacitor. So voltage across the capacitor divided by impedance of the capacitor will give me the current. So this is, of course, through the capacitor. So this is V1 over Z sub C. Okay, so we can say that this is equal, let me write this down over here, sum of the currents at node 1 is equal negative I1 plus 4 over Z sub C times V1, where this is equal negative I1 is equal 5 milliamps, negative of course, plus 4 over Z sub C, which is equal 4 coulombs, an angle of negative 90 degrees, and everything is multiplied by V1. Okay, so I have sum of the currents at node 1 is equal negative 5 milliamps plus, and I have 4 divided by 4 exponent 3 angle 90 negative is equal 1 millisiemens, and angle of 90 degrees. And of course this is my V1. Next, I'm supposed to find the sum of the currents at node 2. Okay, so please notice that current I2 is going to the node, okay, V2, and I is leaving, so I2 is going to be positive and I is going to be negative this time. So I have I equals 8 milliamps, okay, so it's positive, so I have I2 minus I. So I have 8 milliamps minus I, and we found that I is equal 1 millisiemens and angle of 90 degrees V1. Okay, that's what I'm going to write this over here. 1 millisiemens and angle of 90 degrees, and this is my V1. So we found the sum of the currents at node 2. Next we're supposed to write the formula for the two node circuit. Okay, so we have Y11 V1 minus Y12 V2 is equal sum of the currents at node 1 negative Y21 V1 plus Y22 V2 is equal sum of the currents at node 2. Okay, so now I can substitute. Okay, the y's by the numbers, so I have Y11 we found is equal 559.01 microsiemens and angle of 26.56 degrees. Of course, this is my V1 minus Y12, which is equal 500 microsiemens V2, and this is equal sum of the currents at node 1, which is equal negative 5 milliamps plus 1 millisiemens and angle of 90 degrees, and this is of course V1. Second equation, we have negative Y21, which is equal 500 microsiemens, and this is my V1, plus Y22, which is equal 1.5 millisiemens, and this is my V2, and this is equal to the sum of the currents at node 2, which is equal 8 milliamps minus 1 millisiemens an angle of 90 degrees V1. Okay, so now please notice that we have V1s, okay, at the right side of the equations, and we have also V1s at the left side of the equation. So what we are going to do, we are going to combine the like terms. So let me rewrite the equations one more time. So I have 559.01 microsiemens and angle of 26.56 V1, and I'm supposed to move this term with V1 to the left side, so this is going to be minus 1 millisiemens and angle of 90 degrees V1 minus 500 microsiemens V2, and this is equal negative 5 milliamps. Okay, this is my first equation. The second one is negative 500 microsiemens V1. Now I'm going to move this term to the left side because it contains V1, so I have plus 1 millisiemens and angle of 90 degrees V1 plus 1.5 millisiemens V2 is equal 8 milliamps. Okay, so now we're supposed to combine the like terms. So I have 559.01 exponent 6 negative, angle of 26.56 minus 1 exponent 3 negative and angle of 90 degrees. This is equal 901.43 micro Siemens. Okay, so this is 901.43 micro Siemens, and angle of second function exponent negative 56.31, negative 56.31 degrees, and I have minus 500 microsiemens. V2 is equal negative 5 milliamps. Okay, so this is my first nodal equation. Okay, but I forget about V1 over here, so I have to add V1. Next, we're supposed to combine these two terms. Okay, so I have 500 negative exponent 6 negative plus 1 exponent 3 negative angle of 90 degrees. This is equal 1.11 millisiemens and angle of 116.56 degrees. So this is the angle 116.56 degrees, and this is my, of course, V1 plus 1.5 millisiemens. V2 is equal 8 milliamps. Okay, so I got my nodal equations. Next, I'm supposed to find the values of V1 and V2, because my calculator doesn't calculate the linear equations which contain the complex numbers. I'm going to do this manually. I'm going to use determinants to find the values of V1 and V2. So first I'm going to find delta. Delta is 901.43 micro Siemens and angle of negative 56.31 degrees, and I have negative 500 micro Siemens, and over here I have 1.11 millisiemens and angle of 116.56 degrees, and I have 1.5 millisiemens. Okay, so now I'm supposed to find delta. So delta is equal 901.43 microsiemens. I do everything step by step, and angle of negative 56.31 degrees times this times this minus this times that, times 1.5 millisiemens minus negative 500 microsiemens, right, times, let me write this over here, 1.11 millisiemens and angle of 116.56 degrees. Okay, so this is equal I have 901.43 exponent 6 negative angle of 56.31 negative times 1.5 exponent 3 negative. Negative times negative will give me positive, so I have plus 500 exponent 6 negative times 1.11 exponent 3 negative angle 116.56. This is equal 804.39, and I have exponent negative 9, so this is nano Siemens square. Why Siemens square? Because Siemens times Siemens give me Siemens square. Okay, so this is my delta and angle. Okay, I have angle negative 51.39 degrees. Next, I'm supposed to find NV1. Okay, NV1. So I have to replace the first column of my delta by the currents. Okay, so I got the currents in my equations negative 5 milliamps and 8 milliamps. I have negative 5 milliamps and I have 8 milliamps, and I'm supposed to copy the second column from my delta, so I have negative 500 microsiemens and I have 1.5 millisiemens. Okay, and now we're supposed to perform the calculation, so I'm going to do right away on the calculator. So this times this minus this times that. Okay, so I have negative 5 exponent 3 negative times 1.5 exponent 3 negative minus negative 500 exponent 6 negative times 8 exponent 3 negative. This is equal negative 3.5 negative 3.5 micro Siemens amp. Okay, why micro Siemens amp? Because we multiply amps by Siemens. Okay, so now we're supposed to find NV2. NV2 is equal, we have to replace the second column by the currents. So I have to copy the first column of my delta. Okay, so I have 901.43 microsiemens and angle of negative 56.31 degrees, and I have 1.11 millisiemens and angle of 116.56 degrees, and I have my currents over here, negative 5 milliamps, and I have 8 milliamps. Okay, again, I'm going to use the calculator to get the answer right away. So if NV2 is equal, so I have 901.43 exponent 6 negative angle 56.31 negative times 8 milliamps, okay, equals minus 5 negative exponent 3 negative times 1.11 exponent 3 negative angle 116.56. Okay, so this is equal 1.83 micro 1.83 micro Siemens amp. okay, microsiemens amp. So now we are ready to find V1 and V2. Oh, I forgot about the angle. Okay, we're supposed to also add the angle. So I have angle negative 34.3 degrees. So V1 is equal n V1 over delta. So we found that n V1 is equal negative 3.5 microsiemens amp. So I have negative 3.5 microsiemens amp divided by delta, and we found that delta is equal 804.39 nanosiemens square, and I have negative 51.39 degrees. Okay, so I have Siemens and Siemens will cancel out, and I have everything looks good because amp divided by Siemens is equal voltage. So I have 3.5 negative exponent 6 negative divided by 804.39 exponent 9 negative, and angle of 51.39 negative is equal 4.35. This is 4.35 volts, and angle of negative 128.61 degrees. Okay, so this is my voltage V1. If I want to find V2, simply write V2 is equal n V2 over delta. So I have n V2 is equal 1.83 microsiemens amp, and angle of negative 34.3 degrees divided by delta, which is equal 804.39 nanosiemens square, and angle of negative 51.39 degrees. This is equal, Siemens and square will cancel out, and we have 1.83 exponent 6 negative, an angle of 34.3 negative divided by 804.39 exponent 9 negative, an angle of 51.39 negative. This is equal 2.27 volts, and angle of 17.09 degrees. So we found V2. Next, the problem is asking me to find IR1, the current which goes through the resistor R1. In order to find the current which goes through resistor R1, you're supposed to simply find the difference, okay, of these two voltages and divide that by the resistance R1. So we have IR1 is equal V1 minus V2 over R1, which is equal V1. We found this is 4.35 volts, an angle of negative 128.61 degrees, minus V2 2.27 volts, an angle of 17.09 degrees, divided by R1, which is equal to coulombs. So this is equal, let's use the calculator. So we have 4.35 and angle of 128.61 negative minus 2.27 angle of 17.09 equals divide by 2 exponent 3. This is equal 3.17 milliamps. 3.17 milliamps and angle of negative 140.22. Negative 140.22 degrees. Okay, so this is my IR1. And next, the problem is asking me to find IC1. IC1, this is nothing else, just IC. And you can find this by dividing, dividing voltage V1 by Z of C1. Okay, so if you are going to divide V1 by the impedance of the capacitor, you're supposed to obtain the current IC1. So I have V1 divided by ZC1, so this is equal V1, we found this is 4.35 volts and angle of negative 128.61 degrees over ZC1, which is equal 4 coulombs and angle of negative 90 degrees. This is equal, so I have 4.35 and angle of 128.61 negative divided by 4 exponent 3 and angle of 90 negative. This is equal 1.08 milliamps and angle of negative 38.61 degrees. And now we can say that the problem is solved.